Okay, so continuing this ideal dot model. Okay, let me solve one more problem. Okay, basically based on concept of rectifier only. So you have a source is given, B input. Okay, here we have a diode, and here we have one more resistance here, and here we have resistance of 20 kilo ohm, 10 kilo ohm, and 10 kilo ohm. Okay, and here you have another diode. Okay, so say this diode is D1, this diode is D2, and V input value is given to you 6 pi sine omega t. Okay, so this time peak to peak value is given to you, and they're asking what is the average value of voltage V naught, and V naught they are measuring like this. Okay, so find the average, find the average value of V naught. Okay, the same thing what we did in last class. Okay, slightly there are a couple of more resistance involved, but the method is same. So what we can do, okay, we can take a positive cycle. Okay, so once this is positive, automatically this diode become your reverse bias. Okay, so in positive cycle you can make one diode as a conducting and other is open. So for positive cycle, okay, for positive cycle I am making this diode as open. Okay, this diode is open, and this diode will be replaced by a short circuit. Okay, for positive cycle, when this is a positive. Okay, once this is a positive, okay, what will happen? No current will flow through this one, so current will come here only. Okay, so I'm making this as a short circuit. Okay, this is short circuit and this is open, so this is open. Okay, so now current will be flowing from here. Okay, and current will get divided here. Okay, so this current will go here, so this is a one branch. Okay, this 30 kilo ohm is one branch, and there is other branch, and these two branches, these are two are in series because the same current is flowing here, and this another branch. Okay, so if I know the total current I here, I can, by current division, I can calculate the what is the current flowing across 10 kilo ohm. Okay, 10 kilo ohm, this one which we considered here. So I can find my I total I flowing in the circuit. Okay, say I total. So I total flowing in the circuit will be how much? I know this one. I have this one. Voltage is 6 pi sine omega t, and total resistance is 10 parallel to this 30. Okay, this is one branch. So I can write 6 pi sine omega t. This become 10 into 30 upon 40. So this cancel. Okay, so how much will come?
7.5.
7.5. Okay, or let it be like this, 24. So this go there na 6, this goes 24. 24 divided by 30. 24 divided by 30. Okay, pi sine omega t. Okay, so you can write 4 by 5 pi sine omega t. Okay, is correct or not? Is coming 4 by 5? Yes. Okay, now this is your total current. Okay, I want current in this resistance. So if I apply current division, okay, current division, say 8.A. Okay, current division at A. Okay, so I can write the this current. Okay, say this current is I naught. So my I naught will be total current. Okay, 4 upon 5 pi sine omega t into resistance of opposite 10 kilo ohm, okay, divide by total
40.
resistance 40, total resistance 40. So I got my I naught equals to 1 by pi sine omega t, okay, and I will call this is a v naught 1, okay, you can call this I naught 1 also, okay, I'll call this v naught 1, and this is equals to 1 upon 5 pi sine omega t, okay, this current will come, of course, किसमें आएगा ये current, okay, so so now you have to multiply by 10 kilo ohm, okay, so value this 10 kilo ohm, so this will come to you 2 pi sine omega t, okay, so your value will come 2 pi sine omega t, so this will come your v naught, okay, v naught 1 is 2 pi sine omega t, okay, and this is between 0 to t by 2, okay, and second case we have diode here, okay, and this diode is like this, so reverse case this will be positive, this will be negative, okay, so negative cycle, okay, we can call the diode number also, so d1 is conducting, d1 on and d2 off, okay, so that you can remember later, you say this is d2 and this is d1, okay, so your d1 is on, d2 is off, okay, and negative cycle your d2 is on, okay, your d2 is on and your d1 is off, that is non-conducting, so I can now make it like open circuit, okay, and this is your short circuit, okay, now current is coming from here, current is coming from here, current going here and here, so current division taking place here, okay, now this current will go here, there's an open circuit, so no current will flow here, okay, so I will call now this point as a b, okay, or better to call point b here, this is not, okay, say this point a, again a dash, so current going here, okay, and current is going to, this is one branch and this is another branch, okay, total current will flow from here, combined current will go here and then will come back here starting from here, okay, so say this time total current, say again say it dash, okay, so it dash total current, okay, second case in negative cycle, so again you have the value is 6 pi sine omega t, and resistance this time is how much,
10.
these are the series 10, okay, so 20 parallel to 20, okay, so this you have 10, okay, so 10, so 6 by 10 means how much, 3 by 5, 3 by 5 pi sine omega t, and since current is flowing like this, so voltage again in the same direction, earlier also we get like this, now also we are getting like this, so this time I call this voltage as a v02, okay, you can mention there in circuit, this is a v02, so v02 will be 3 pi and you have to multiply by 10, so you get 6 pi sine omega t, okay, but this I cannot put period here, once I put period, okay, the sine omega t function is there, so whether you to see you will take positive or negative, okay, now let me plot the
10
uh,
into 10
huh,
raised to 3, na? 10 kilo
huh,
ohm.
huh,
Resistance is 10 kilo ohm, na?
huh.
So 10
Here
into
also, so current also is milliampere, na? Then that will cancel. It will come volt. Okay. Current also is milliampere, na? Because once you put this kilo ohm, so that will come in milliampere only. So now,
सर
हाँ,
जो करंट है वो टोटल करंट है ना,
ये वाला
वो I2 भी
आई
कौन
टू
सा?
भी निकालना पड़ेगा।
हाँ, अभी निकालना पड़ेगा. Sorry. Correct. Okay. So this is IT. Now we have to calculate I naught 2. Okay. So that will be total current. Total current is 3 by 5. Okay. Now here is 20 resistance. Here is 20 resistance. So current will divide. Okay. Current will divide. Current will divide. That means how much you get now? You get 3 by 10. Okay, so the final answer come 3 pi by sine omega t. Very good. Okay,
Yes.
sine omega t. Final answer is the output V naught 2. Okay, you have to calculate current I naught 2, I naught 1 also, I naught 2 calculate, and then V naught 2. I naught 2 will be half of this one, 3 by 10. And you can write now, or I have to write. You can write. Okay, oh, let me write here. So I naught 2 will be your 3 by 10 pi sine omega t by current division, and V naught 2. Okay, so V naught 2, let me write here. So V naught 2 is 3 pi sine omega t. Okay, let me write here minus here because both are in the same direction. Okay, I'm changing the period na, so this will be t by 2 t t. Okay, because what is happening, I am giving an input. Okay, I'm giving an input, so input is V input t. Okay, and V output I'm getting both times same direction. Okay, so both times same direction. So if I want to represent this as a function, I cannot use sign, I have to put minus here. Okay, because the period is changed, this period sign is negative, so I have to put minus here. Okay, now you know the function, you can easily calculate the v average. Okay, calculate the V average. So now VDC, okay, VDC is 1 upon T, okay, VT dt 0 to T, okay, so 1 by T, okay, 0 to T by 2. The function is 2 pi sine omega T, okay, plus 1 by T, okay, T by 2T, okay, function is minus 3 pi sine omega T sine dt. Okay, tell me how much is coming, solve it and tell me how much is coming.
Sir, -5.
-5 or +5? Check it one times. Okay,
+5.
+5, yes. One minute. Okay. So this will come +5 volt. If you solve this one, okay, this should come +5 volt. Other please also check. Okay.
सर टी क्या सब्स्टिट्यूट किया है हमने
2 pi by omega. T से टाइम पीरियड है ना, 2 pi by omega करना पड़ेगा.
तो सर आंसर पूरा आ रहा है मतलब कैपिटल टी कुछ तो सब्स्टिट्यूट किया
तो बताया ना आपको, 2 t को 2 pi by omega करेंगे ना, टाइम पीरियड क्या होता है, 2 pi by omega आ रहा है और ओमेगा वहां से भी आएगा. या तो इसको लिखो तुम, हाँ, इसको टी रहने दो,
यस
जो ओमेगा आ रहा है उसको 2 पाई बाय टी लिखो, कैंसिल हो जाएगा. ओके, सो नाउ, ओके, this problem came in gate. Okay, so you have I equals to b minus 0.7 500. Okay, for v greater than 0.7. Okay. Okay, and 0. Okay, this problem I should have done later. Okay, no problem, we can do it now also. 0 per 1 b less than 0.7. Okay, so I have been given a diode. Okay, so and they have given you resistance 1 kilo. Okay, so this basically diode is not ideal in this case. Okay, this is a diode which is a constant model, but no issue, we can do it now also, this problem. So he says that current I will be flowing in the circuit, okay, for v is greater than 0.7. Okay, so whenever here your v is greater than 0.7, okay, so this much current will be flowing in the circuit, and you have to find out what is the value of v in this circuit. Okay, how much voltage is getting drop across diode. Okay, so just if it is v is greater than 0.7, then this much current is flowing. Now you can easily find out how much voltage is flowing in the circuit, how much voltage is there across diode if you make it open. Okay, if we just make it open, so you can see whole the voltage is getting drop here. Okay, if you see the voltage greater than your 0. All the voltage is getting drop here. That means I can use this current equation. So obviously my v is here greater than 0.7. I'm 10 volt applying. Okay, now I can take and if v is 0.7, you can take 0. So I'm taking the, I'm assuming this case. Okay, and I'm calculating current and voltage value. Okay, so if I assume this is less than, then this will be open. Okay, so if you make this open, then we see all the voltage coming here. So this is not current will be of course 0, and voltage will be whole the 10 volts here. Okay, current will be 0. That is correct. Okay, so if it is, so we assuming the circuit this case. So my current is now given by this equation. So if I write the KVL, this is minus 10. Okay, and then I have a I into 1 kilo ohm. Okay, and then I have this voltage V that is equals to 0. So minus 10, I is V minus 0.7, 500, 10, 3 plus V equals to 0. This become 2. Okay, so I have minus 10 plus 2V minus 1.4 plus V equals to 0. And how much will 3V? 3V and this become how much? 11.4. Okay, 11.4 volts. So how much V will come? So we should come almost 3.8 volt. Okay, so this the value of V is 3.1 volt. Okay, and this problem came in GATE exam, GATE net both. Okay, so net 2014 also it came, net 2014. Okay, and this
सर
came in East
Sir,
GATE. Yes.
सर इसको हम फॉरवर्ड बायस करके भी कर सकते हैं, जैसे ये शॉर्ट सर्किट करके.
शॉर्ट सर्किट नहीं कर सकते इसको, क्योंकि शॉर्ट सर्किट में आप दे विल बी गिव द डायोड इज आइडियल. ओके, they will tell the diode is ideal. So this diode is not ideal. Okay,
ओके
some
सर.
voltage getting drop. Okay, basically this is a constant drop voltage drop model. Okay, but I have done this before. Okay, no issue.
sir,
So
when
so
if
you
we
can find
consider
current value also. हाँ बोलिए.
a reverse bias case, na, in
हाँ
that case voltage will be negative, na, across.
हाँ obviously. If it refer, but how can you assume reverse bias? Okay, you make it open, you see plus voltage is coming here, so it is of course not reverse bias.
Okay, sir.
Now you can find the current value, how much current is flowing. Somebody calculate the current value. Now you know the V, and tell me the current, how much current is coming. So current will come 3.8 volts minus 0.7 upon 500. Okay, so this
6.2 milliampere.
yes, so this become 6.2, okay, milliampere. Same type questions, one more came in exam. Okay, we have 10 volt. Okay, and they say this is your VD and this is 1 ohm. Okay, to say calculate VD. Okay, calculate VD. Okay, if ID current is flowing like this, VD square plus 2 VD. Okay, if V for VD greater than 0 and 0 for VD less than 0. Okay, so this is not an ideal diode. Okay, some voltage already they given, VD is getting drop here. So they say if VD is greater than 0, then this much current is flowing in the circuit. And of course, when VD is less than 0, this then it will be reverse bias. So no current will be flowing in the circuit. Okay, so assuming the current is flowing in the circuit, calculate the value of VD. Okay, so say similar type of questions. If you do minus 10, okay, say I current is flowing, circuit ID is flowing, ID into 1 ohm or 1 kilo ohm. Okay, let it take 1 ohm, 1 ohm. Okay, and plus VD equals to 0. Okay, minus 10. ID is your given VD square plus 2 VD. Okay, plus VD equals to 0. Okay, now you have VD square plus 3 VD plus minus 10. Minus 10 equals to 0. Okay, so this is a quality equation. You will get two values of VD. VD equals to how much coming?
2 volts.
If we solve this one,
Minus 5 and 2.
minus 5 and 2. Okay, so but we are assuming the VD is positive. That's why we are assuming this current is flowing, isn't it? Okay, so we cannot take negative values. So our answer is 2. Because we are assuming this positive, then only this current is flowing.
Sir, answer is
2, 2. Okay,
The 2 or minus 5.
2 and minus 5.
Positive I नहीं है sir.
So minus 5 we cannot take. Minus 5 we cannot take. Okay, because we assume that VD is positive. So 2 is answer.
Okay.
Now you have been given one circuit. You have been given a sine wave. Okay, 20 sine omega t. Okay, so your V input is 24 sine omega t, and you have been given this one resistor. You have been given a diode, and then you have been given a 12-volt battery here. Okay, and this is your 100 ohm. 100 ohm, and this is your R. Okay, so they're asking number of questions. They're asking find the fraction of cycle, find the fraction of cycle, okay, during which diode conducts, during 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 which diode conducts. Okay. Number two question they're asking peak value of diode current. What is the peak value of diode current? Okay. And number three asking maximum reverse bias voltage on diode. Okay. Maximum reverse bias voltage on diode. So you need to answer these three questions. Okay. So diode, assuming diode is ideal. Okay, assuming diode is ideal.
सर ये क्वेश्चन में मतलब अगर मतलब मेंशन होगा ये चीज की आइडियल डायोड है.
Yes, yes, yes. This will mention. This will mention the ideal diode, or they'll say it's a silicon diode. Okay, and constant voltage 0.7. So this will be given. Okay. Now, how can we approach this question? Okay. So first of all, we need to see whether diode conducts or not conduct. Okay, whether diode will conduct or not conduct. Okay. So for example, can I read this one?
Yes, sir.
Okay. So say I have a resistance. Okay. Forgot this one. Suppose I have a resistance. Okay. And I'm applying a source here. Source, say 12 volts. And I'm applying a source here equals to 12 volt. Okay. So can you tell me how much current will flow in the circuit?
0.
Okay. So until this voltage doesn't get greater than this voltage, okay, current cannot draw in the circuit. Current cannot flow in the circuit. Okay. Why? Because this here there is no drop. If here is some drop, then we can calculate. Suppose this is 0.7 or 1 volt. Then I have to add this 1 volt also here. Okay. Then I have to get the condition of getting this diode to draw. But this is the ideal diode. Okay. So whenever this will conduct, this will be short circuited. So that means if you assume this is short circuited, okay, even then you need this voltage has to be greater than this 12 volt, then only current will flow. Okay. So now if I, okay, so this will be I0 in this case. Okay. So now if I have, suppose my input I have been given this my input. Okay. This is my V input. Okay. Which is equals peak value is 24. Now I have to get my current to flow. Okay. So diode should conduct. Okay. So diode will only conduct when my value is V output value. Okay. Is or V, this value should be greater than this 12 volt. Okay. This period. So only this period my diode will conduct. Sorry, output on the output. Okay. Only this cycle, this period, here to here, here to here. That means this much cycle this much part of the cycle my diode will conduct. Okay, when it is positive cycle,
Sir,
when it is reverse bias,
is on another side, that's why, na?
huh?
12 volt is on another side, that's why.
12 volts, 12 volts. Okay, so until this is up 12, it cannot conduct. It should be greater than 12. Okay, and reverse side, when you pick a reverse side, it will automatically open, so no current will flow. Diode will not conduct. Okay, so you can write for positive cycle. For positive cycle, okay, diode conducts. Diode conducts. Okay, when my Vi is greater than 12 volts. Okay, and reverse bias in negative cycle. Okay, diode is off. The current is zero. Diode is off. Okay, so current is I is zero. So I is zero. So no current flows. Okay, or diode do not conduct. Okay, now I have to calculate how much part is this fraction of this cycle. Okay, so I have been given the equation Vi equals to 24 sine omega t. Okay, so this point, say this point is omega t1, and say this point is omega t2. Are you getting this point? Okay, there will be some time. Okay, say this scale is omega t1, omega t. Okay, so from this point to this point my diode is conducting. So in this point my voltage is 12. Okay, so my V input is 12. So I can say this is happen on omega t1 time. Omega t1 time, this is sine omega t1. So from here I can get sine omega t1 is equal to how much? 1 by 2. So my omega t1 is now angle is this time is
Pi by
in
6.
angle pi by 6. Okay, this is a pi by 6 or 60 degree. Pi by 6. Okay, now these are symmetric. So this is 180. This is pi. This is pi by 6. So this gap is also pi by 6. So this point omega t2 will be pi minus pi by 6. Okay, how much? 120. How much?
Pi by 6.
Pi by 6. Okay, just we write 120 degree. This will be 120 degree, and this is say pi by 30 degree. Okay, so 30 degree to 30 to 120 it is conducting. Okay, so how much is conducting for how much time? Just check answer. Omega t1 is 30, and that is 30 minus, sorry, 30 minus pi by 6. So this is not pi, this is 150. This is 150. 5 pi by 6 is 150. Okay, so that means my diode conducts.
Sir,
एक minute. Diode conducts. Okay, for omega t2 minus omega t1, that is 150 minus 30, that is for 120 degree. Okay, 120 degree. That means the fraction of cycles conduct, fraction of cycle. So total cycle is 360 degree and 120 degree. So almost 1 by 3 1 by 3 cycles diode conducts, and other time it is reverse bias, or the current is not flowing. हाँ बोलिए.
सर प्लीज एक बार ओमेगा T2 का कैलकुलेशन बताइए, पाई कैसे मतलब लिया?
ये गैप कितना है? पाई बाई 6 है.
पाई बाय 6 है.
ये गैप भी पाई बाई 6 होगा.
यस.
सिमेट्रिक है. तो ये टोटल 120 है, ये 80 है. 180 माइनस 30 कितना आएगा? 150. This is 150.
यस.
Okay, and this is your 30. So the total gap is 120 degree. It is problem is clear. This problem is clear to you.
Yes, sir.
Okay, this is the first part. Second part, what they are asking?
Peak value of diode current.
So resistance you have given this one. Okay, so obviously peak value will be how much? So say this is the value of peak value. Say peak value is say 24. Okay, so when positive cycle, this is negative, this is positive. So I'm taking 24. Okay, here say I, okay, I peak into R, and then this become, when it's conducting, this becomes short circuit. Okay, and you have now plus 12. So I peak will be how much? I peak will be your 24 minus 12 upon R is 100. Okay, so 12 upon 100. So how much will come? 0.12, 0.2 ampere. Okay. Now, in third question, they're saying the maximum reverse bias voltage on diode. Maximum reverse bias voltage on diode. Diode is already reverse bias. Okay. In reverse bias, it will open, and reverse bias, this will be your minus, this will be your plus. Okay. So I want to calculate how much maximum voltage is coming here. So for maximum, I need to take this is a peak value. Okay. So now the situation like this. So I have a minus 24. Okay. So this will be your this. Okay. So they're asking like this. Okay. What is the voltage here? You can ask. They can ask like this also, but they're asking like this. How much voltage is there? Okay. So how much voltage will come to diode? Because diode this, हाँ diode is positive. हाँ हाँ बोलिए.
सर
Yes.
इसमें हम ऐसे assume नहीं करेंगे कि जैसे 12 से लेस वोल्टेज होगी तब ये रिवर्स बायस होगा, तो अब नेगेटिव साइकिल ले रहे हैं हम.
रिवर्स बायस तो हमेशा रहेगा. जीरो से जैसे भी नेगेटिव साइकिल भी ऑलरेडी रिवर्स बायस है. नेगेटिव से तो और नेगेटिव हो रहा है ना.
यस यस.
ये तो डबल, ये तो ऑलरेडी रिवर्स बायस है. अब ये करने से तो और रिवर्स बायस हो रहा है. तो ये तो उसको सपोर्ट कर रहा है उल्टा. गेटिंग?
ओके ओके.
Okay. So now this is minus 24 minus 12. Okay, minus VD equals to 0. Okay, so your VD will be now 36.
minus 36.
So this is answer.
minus 36 आ जाएगा ना सर.
minus 36 मैं ऐसा ले रहा हूँ ना, ऐसा आएगा.
सर ऐसे भी तो minus 36 ही आ रहा है.
सर ये
तो कैसे लिया आपने?
अगर पॉलिटी वैसे मेजर करो. अच्छा, ओके, करेक्ट करेक्ट. दिस इज प्लस माइनस, दिस इज प्लस माइनस, takes to minus 36 volt. If you take like this polarity, but if they give you tell like this, okay, plus to plus minus minus, then a polarity will change. Then you can take minus 36 volt.
सर ये माइनस VD इज इक्वल टू माइनस 36 वोल्ट आ रहा है ना.
If you take this, if you like this measuring this, if you're making reverse bias voltage negative, because diode is like this na. Okay, so you're getting plus here, minus here. This voltage will be always negative. Okay. So this is your. Now this was your ideal model. Okay, we did some model, some problem where diode was ideal. Okay, now we are seeing constant voltage drop model. Okay, this was ideal diode model. Now constant, okay, voltage drop model. Okay, constant दिख रहा है ना, voltage drop model, और constant voltage model भी बोलते हैं. So constant voltage का मतलब क्या है? You have diode already we have seen. This is my diode characteristics, actual diode characteristics. Okay, and we told this is your reverse bias before the breakdown to happen. So we'll always assume the current in the circuit flowing before the breakdown. Okay, that means your diode is in working condition. It's not working in breakdown conditions. So diode is in, so this voltage is before the breakdown. Okay, so now this model says ki here current is exponential. Okay, so this IV characteristics can be approximated by this type of curve. So reverse bias, again you have a zero current. Okay, so this is the reverse bias and this is your forward bias. So what is the meaning? Okay, so if your diode is in reverse bias, if diode is in reverse bias getting here, okay, then you can, like previous case, you can assume your diode is open. Okay, in reverse bias you have same situation, diode is open. Okay, now if it is forward bias, okay, in forward bias, if diode is forward bias, okay, in that case you have to check that which diode is, it is made of silicon. So if it is silicon, okay, then you have to take now constant drop across the diode. Okay, so they will tell you how much drop you take. If it is silicon diode, generally the drop is 0.7 volt. This is 0.7 volt for silicon. Okay, and this is 0. For germanium, it is 0.3.
That's crazy.
0.3. Okay, so you can take this is 0.3 in the case of germanium and 0.7 the silicon. Okay, they will tell you in the question that voltage drop of take 0.7, or if they don't tell, this is silicon and then also you take 0.7. Take germanium, you take 0.3, but this is silicon with ideal. Ideal means 0. Otherwise you have to take 0.7 for silicon and 0.3 for germanium. Okay, so in that case you can replace your diode by a battery. Okay, in forward bias, but the condition is that your VD across diode, okay, across diode the VD should be greater than, okay, 0.7. if it is greater than 0.7, okay, then only you can replace by battery. So you have to always check whether diode is forward bias or reverse bias. So in order to check diode is forward bias, you need to open this one diode and see how much open terminal voltage is coming. If open terminal voltage is greater than 0.7, diode is forward bias. Okay, in reverse it is always reverse bias. So you can replace by battery in forward bias and you can open circuit by in reverse bias. This is your constant voltage drop model. Other things are same. So
सर ये
let me
0.7 सिलिकॉन है ना, फिर जर्मेनियम में 0.3 से कंपेयर करेंगे.
VD was 0.7. हाँ 0.7 से ऊपर होना चाहिए ड्रॉप across the diode इसको फॉरवर्ड बायस बनाने के लिए सिलिकॉन को, और जर्मेनियम
0.3 ना
0.3.
सर 0.7 पे भी वो फॉरवर्ड बायस ही होगा ना, बैटरी से ही रिप्लेस करेंगे ना.
और क्या ज्यादा whenever more than 0.7 you get open circuit voltage. Okay, this VD is open circuit VD, open circuit. Okay, so then diode is in forward bias and you can always replace this by battery. Are you getting my point? You have to see how much voltage coming across the diode. If it is greater than 0.7, then it is, you have to assume this is a forward bias and then you can replace by a battery. Okay, I'll show you some problem, then understand. So you have been given a resistor and you have been given a 5 volt, you have 1 kilo ohm, okay, and then they have silicon. Okay, silicon means here 0.7. okay, so first you have to check, okay, how much open circuit voltage is coming. Okay, so make it open. 5 volts. Okay, 1 kilo ohm. Okay, and you make diode open. So how much voltage is coming here? How much the voltage here?
5 volt.
5 volt.
5 volts. Because no current is flowing, so no drop here. 5 volts. This means this diode is in forward bias. This diode is in forward bias. So once it is in forward bias, what you can do? You can replace this diode by a, okay, diode is forward bias. Once diode is in forward bias, okay, you can replace diode by a battery. This is your, this become your battery. Sign would be this is positive, this is the negative plate, positive negative plate, 0.7. Now you have 5, okay, you have 1 kilo ohm resistance. Now you can find what is, how much current is flowing in the circuit, ID. Okay, so your ID will be, of course, now drop is there, so some there will be some less current, and ID will be 5 minus 0.7 upon 1 kilo ohm. Okay, that is, your ID will be now 4.3. Okay, 10 to the power minus 3 ampere. It is 4.3 milliampere. Okay, this for, now what is VR? How much is VR in this question? If I say this is VR, what is the value of VR? What is the voltage drop across resistance?
4.3 volt.
Current will be
Point
same.
Hmm?
4.2 into 1.
If 5 यहाँ पे हो रहा है, this is 0.7. So voltage across VR will be 5 minus 0.7, that is 4.3 volt. Okay. Now let me solve one problem. Okay. You have been given a diode like this. Okay. You have a resistance 2 kilo ohm. Okay. You have a battery to 2 volts, and you have a resistance 6 kilo ohm. Okay, and now they say if find the current I. Okay, find the current I in the circuit if diode is, okay, is silicon, is made of silicon. Okay, silicon, that is the voltage drop across will be 0.7. Diode is silicon. Second, diode is germanium, and third is diode is ideal. Diode is ideal. Okay, all the three cases you need to find the current.
सर फर्स्ट केस में तो वर्क नहीं करेगा 0.7 में.
So you always you need to take where current will go through this one or not. Okay, so you have to check how much voltage is coming across the diode, open circuit voltage. Okay, so the first case, okay, always when it is silicon. Okay, so you have to check. Now say I'm taking first case, my diode is made of silicon. Okay, first case. So I'm taking now first case silicon. Okay, now if it is silicon, there should be must the voltage 0.7, then only it will conduct, otherwise it will be reverse bias. Okay, so always check how much voltage is coming here, how much voltage is coming here. Okay, so if you check the voltage across open circuit voltage, okay, open circuit voltage, okay, that is coming now. How much current open circuit voltage we open across diode, okay, that is coming your 2 total voltage 2, resistance is 8 kilo ohm into 2 kilo ohm. Okay, this voltage is same like this voltage. Okay, you say this is VD. So VD is coming open circuit VD. Okay, open circuit VD, VOD, open circuit VD, B open circuit diode voltage, diode is coming kilo ohm cancel. This become 1/4. So this is 1/2. This is 0.5 volts. Okay, that is less than 0.7 volt. So in this case, your diode cannot conduct, so it will be act as open circuit. Okay, now you can find the current, whatever current we calculated, current I will be simply your 2/8 kilo ohm. That is how much? 1/4. Okay, 0.25. Correct. 0.25 milliampere. The first case answer will be 0.25 milliampere. Is correct or not?
Yes, sir.
Yes, sir.
Second case में 0.28 milliamp.
0. Second case.
28, sir. Yes, sir.
Second case. Okay. Now second case is for germanium. Second case is for germanium. Okay. So open circuit voltage coming 5 volt here. So to diode second case. Okay. Your diode will be conducting. Conducting. It can be replaced by a battery of 0.3 volts. Okay. Now it can be replaced by a battery of 0.3 volts. Okay, so now here voltage is how much? 0.3. remaining voltage come here, so you can find the current here. Okay, so in second case when you have germanium, okay,
सर एक मिनट
so
सर
always remember, when you're making open, you're getting the open circuit voltage. So whenever you add something here, this voltage get decreased. Are you getting my point? Once it is open, the current is flowing like this. No current is going here. Screen blur होगी. Sutton, screen blur है क्या?
सर बीच में हो रहा है सर.
क्लियर हो गया
Okay. Okay, just 5 minutes more. Okay. So now, so whenever diode is open and you add something, some device here, this voltage will always decrease because now there is a current division. Are you getting my point? So now, so open circuit voltage was 0.5. As soon as I add the diode and it's conducting, and the drop, this becomes 0.3 because now there is a current. The current is going here also. Some current is going here also. Okay, and remaining current is coming here.
सर
So in this case, हाँ,
सर इन लास्ट केस 0.5 इज लेस देन 0.7 इट मींस मतलब हमारा डायोड कंडक्ट नहीं करेगा ना,
डायोड कनेक्ट नहीं करेगा.
तो उसके लिए मतलब 0 वोल्ट भी आउटपुट लेंगे.
डायोड विल बी ओपन. कनेक्ट नहीं करना मतलब क्या? रिवर्स बायस में है, ओपन है,
यस
तो
सर.
करंट जाएगा ही नहीं. ओके, करंट जाएगा नहीं तो सारा करंट यहाँ फ्लो कर जाएगा. तो हमने वो टोटल वोल्टेज डिवाइड बाय टोटल रेजिस्टर करके करंट निकाल लिया.
ओके सर. ओके.
Now second case we have on this current. Now current is flowing here also, and this current I don't know what is the current value, but I can know what is the voltage here. I know resistance here. I can calculate the current here. Okay, so now this voltage, this voltage is 0.3. Remaining voltage here, voltage is 1.7. Okay, so voltage across 6 kilo ohm, okay, is your now 2 minus 0.3, that is 1.7 volt. Okay, and again I can calculate I will be 1.7 divided by 6 kilo ohm, and this just now turn told. How much is coming this one? 0.028 milliampere. Okay, 1.76 into 10 to the power, so 0.028 milliampere. The second case. Okay, and third case is pretty simple.
0.3 kilo.
Huh?
2 minus 0.3.
0.028, 0.02 is not coming.
सर
हमने आईडी करंट
पॉइंट
नहीं निकालना, आईडी
आईडी नहीं निकालना, ये करंट निकालना है, ये वाला करंट। आईडी कैसे निकालोगे? ओके, आईडी you can also find now. Okay, because this current you know, and this voltage you know, this resistance also you know, so you know this current also you know. So this current you know, this current you know. So this current minus this current will be this current. How much is coming here? That also you can find, isn't it?
Sir,
But question में they ask this current.
ओके ओके
Okay. Any doubt?
नो सर ओके
So this is your current. Okay. So now third point is when diode is ideal. Diode is ideal. Okay. So when it is ideal, no need to think. Just check voltage here, whether it's forward bias or reverse bias. So it is forward bias. This can be replaced by a short circuit. Simple. Okay. So when this is short circuit, that means no current is flowing this diode. All the current is going here, isn't it? This resistance becomes short, so we cannot consider this resistance. So only my current will be, I will be how much?
0.33.
Okay, 0.33 milliampere. That's all. So so I'm giving you one homework. Okay. Like previous, this is previous case. Okay. This is your VS. Okay. And this is your 50 ohm resistance. Okay. And your VS is given like this. Your VS at this time is square wave pulse. Okay, square pulse, which is maximum is 8 volt and negative is minus 10 volt. This is your VS. Okay, and this is your 50 ohm. 50 ohm. Okay, so you need to find, okay, average of V load. Okay, find average of VL. Average of VL. Okay, I'm giving you answer also so that you can check later. Okay, so the answer of this problem is minus 3 volt. Final answer is, my answer is minus 3 volt. Good problem. And you have a circuit, 12 volt. You have a diode. You have a diode silicon. You have a diode germanium. That means 0.7, 0.3. Okay, and then you have a 5.6 kilo ohm resistance here, 5.6, and this is grounded. Okay. So, and this is here I'm measuring B naught, and this current is flowing here. Okay. So you need to tell me what is ID in the circuit, current ID, and what is V naught. Okay. This is your homework. Okay. So I'm stopping here. In doubt, please ask.
So for first case, it is ideal diode. For first case.
First case is idle diode. Yes.
Okay.
Okay. So I'm stopping
Thank
here.
you, sir. Thank you, sir.
Thank you.
Thank you, sir. Good night, sir.
Thank you, sir.